Okay guys, thanks for tuning in to the tutorial part of the Mod 1 review book. The questions that you see here are not the exact same questions that appear in your book, although the concepts are pretty much almost exactly the same. So whatever I do here, you can do with your numbers and your story problem, your word problem on your own at home. Feel free to hit pause at any time to work through your problems as I work through my problems here on the screen. All right, the first page is just all about basic ratios. We look at the first question, our given ratio for McDonald's employees, which is 3 managers for every 15 employees. When we write ratios, we can write it 3 ways. We can do it as a colon in between 3 and 15. We could write it out 3 to 15, or we can express it as 3 over 15. All 3 are fine. And I know we've had some questions so far about the value of a ratio. Value of a ratio is really the ratio in its simplest form. Think of it as like a fraction almost. And you're reducing it to simplest form, which in this case is going to be 1 to 5. If you want to hit pause on your video blog, you could do the first 2 questions on your own sheet, and then you can come back here. All right, the next is our ratio table. On your particular Mod 1 review book, you're dealing with cafeteria utensils. I have 3 colored marbles, the black, the white, and the yellow. The order in which we list our ratios does matter. So if it lists black marbles to white marbles in our sentence, we have to list it as black to white in our ratio, which in this case is 38 to 40. It is not the same as 40 to 38, so make sure that you list it in the way it appears in the sentence. Value of the ratio is reducing it into its simplest form. They're both 38 and 40 are divisible by 2. So on my end, I wind up being able to reduce it to 19 to 20. And that's the value of the ratio. Now we're going to do yellow to white. My yellow is 18, and my white is 40. Both are divisible by 2 again, so I'm going to find the value as 9 to 20. And we're going to do white to total. My white marbles is 40. In order to get total, I have to add them all up, and on my end, I wind up with 96. Value of the ratio. You'll see we can continue to keep splitting this in half until we get the value. If I divide both 40 and 96 by 2, I wind up first with 20 to 48. They're both even numbers, so I could split them in half again. 10 to 24, and I can do it one more time. 5 to 12. In actuality, the 40 to 96 were both 40 and 96 were divisible by 8. And that's how I wind up with the value being 5 to 12, which is my final answer. Also understand that these are all equivalent ratios. Equivalent ratios are being asked from question number 9, where they're giving you the value of the ratio, 2 to 3, in this different bag, which is green to blue marbles. I'm going to express my given ratio as 2 over 3. And when we build equivalent ratios, we can find a multiplicative value for both the denominator and the numerator. And I'm going to create 4 to 6. If I want, I can multiply by 2 again. And I get 8 to 12. Then I can do it again and get 16 to 24. And there are a lot of others. Obviously, it goes on for infinity. Those are my 3. The other way you could do it too. I told you guys a while back, you could just take the easy way, the shortcut. You just add a 0. It's like multiplying both by 10. And you can get one equivalent ratio that way. All right, let's move on to page 2, which is all about tape diagrams. Back in the first quarter. This is where I feel like everybody does need a refresher. I'm going to tell you the same thing I told you back in the first quarter with any word problem. Get the gist of the question. Read it. Find out what it is you need to do. We'll do it on my end first, and then I'll give you guys time to do it with your particular question. My number 10 is about stamps and baseball cards. I'm going to read it to myself, and I'm going to underline my key VIPs, things that I know are important that I'm going to need. First thing I'm going to underline is my given ratio, which is my 3:7. I'm going to need that. My 60 stamps is a key VIP. And the gist, or what they're asking for us to do, is in that last statement. How many baseball cards does he have? From there, we're going to build our tape diagram. Our given ratio is always, always, always going to be our tape diagram. It's 3:7. I'm going to build a tape diagram showing 3:7. Order does matter, so I want to make sure I know what's 3 and what's 7, and it's going to appear as it appears in the sentence. Stamps comes first to baseball cards, therefore 3 is stamps and 7 is baseball cards. I'm going to build 3 segments or 3 boxes for stamps, and I'm going to build 7 segments for baseball cards. Now that's assuming right now that each box has a value of 1. That's my 3:7. I'm now going to go back into the question and find the next piece of information that I'm going to need. And my next piece of information is my amount of stamps, which is 60. 60 stamps is being represented by 3 of these boxes in my tape diagram. I'm going to put a 60 above here. What I'm doing is I'm taking my 60 and I've got to divvy this up 3 ways. I've got to make 3 equal portions of 60. So what you're really doing is it's 60 divided by 3. That's going to give you what the new value is for each box. And if you do that, you wind up with 20, 20, 20, all adding up to 60. What's neat about that is once you find the value of the box for each, or the value for each box of stamps, the same will hold true for every single box that's remaining for baseball cards. It's like the key that unlocks the problem once you find what those boxes are worth. Now all we got to do is count up all of our baseball card amounts, and that's going to give us our answer. Well, yeah, I could go 20 plus 20 plus 20 plus 20, or I know there's 7 boxes here, so it's 20 times 7. And that's going to give me my answer. He has 140 baseball cards. And there's 2 other directions that a question like this can go in, and I'll just briefly bring it up. They may also ask, what's the total amount of baseball cards and stamps combined? And if they ask that, you've got to take the 60 stamps that we have here, and our answer for that then would be 200, because we've got to add it to 140. What I've also seen, and you'll see it actually as a question later in your book, is the difference in the amount of stamps to baseball cards. Since I have 60 here and 140 here, they could ask how many more baseball cards does he have compared to stamps. And if that's the case, you would subtract 140, take away 60, and he has 80 more baseball cards than stamps. And I'm just throwing that out there because there's different ways that they can ask that final question. But the idea still being is if you could find out what one box is worth, you could pretty much answer any question that they give you. Method 2, same question, just a different way to do it. that you might be more comfortable with, and I wanted to expose that to you as well because it's been a while. And that's our template ratio find method. Our template is here. It stamps over baseball cards. They kind of serve as placeholders, where to put our given ratio and where we're going to put our find ratio. The given ratio is exactly as is. It's our given ratio in the question. It gives you both the stamps, which is 3, and our baseball cards, which is 7. And we're going to plug that in to our given ratio. The reason why I make these labels is because they're placeholders. I know that my stamps have to be on top, my baseball cards have to be on my bottom. It kind of reminds you where everything needs to be placed in order to figure it out, because if you flip it by accident, one or the other, you're going to wind up not getting the right answer. Now, I could do 2 things for my find. I could look back at the question and see, what is it am I trying to find? Is it baseball cards or stamps? The last piece there tells us that how many thing. You're looking for keywords, how many, how much, how little, how small. The answer to what we're trying to find is in that sentence. In this case, it's baseball cards. That's our unknown. I'm going to put a question mark for that right now. Now we go back and say, okay, they've given us that last piece of the puzzle, which is 60 what? 60 stamps. That's going here. Why here? Because we've established that in our template. Anything pertaining to stamps is at the bottom. Anything having to do with baseball cards, I'm sorry, stamps is the top. Baseball cards is the bottom. Now we just have to see, we've created here an equivalent ratio. To get from 3 to 60, we're multiplying by how much? The other way to look at it is, if you go the other way, it's 60 divided by 3, which is what? Well, the answer happens to be that we're multiplying by 20. Once you figure that out from the top, you do that with the bottom, and you wind up having the same answer. Two ways to get the same answer. Okay, let's take a look at the next question. Number 11. Also a tape diagram, and this is that difference question that I told you about. Same thing, you're going to want to read the question and get an idea, get a feel, get the gist of what they're asking us to do. Underline our key VIPs. I need my ratio. I'm going to underline difference. It's in capital letters for a reason. 36 more black cars, and I'll do then silver cars, that's fine. And then what they're asking, how many black cars and silver cars are in the parking lot? And we got to do a tape diagram. I'm going to set it up as black to silver. Our given ratio, 7 to 4, is always our tape diagram. 7 boxes to 4 boxes. There they are. Here comes my 4. All right, next thing I'm going to do is look at my next sentence. So they're telling us there's a difference of 36 more black cars than silver cars. We're going to use our tape diagram, it's a model, to figure out what the value is based on that information, 36, of what each box is worth. I set this up perfectly aligned for a reason, because I wanted you to see that in our tape diagram we have 3 more boxes than we do for, we have 3 more boxes for black than we do for silver. So I'm concerned with these extra boxes here. This is my difference. This is how many more black I have, tape diagram wise. And our question tells us, in reality, these 3 boxes represents 36 black cars. So you're going to go and do this exactly the same way as you did the previous problem. That 36 has got to be divvied up equally 3 ways. That's going to then make a value of 12 for each box. What I've really done is 36 divided by 3. and that's our 12. And once you find that key piece, that 12 is good for every single box. It's the key that unlocks everything, as I tell you guys. You found the magic number. Now it's just a matter of applying that and multiplying properly. What's the shortcut for black cars? We know that there's 7. Black cars is going to be 12 times 7. Silver cars, there's 4. 12 times 4. You wind up with 84 black. And you wind up with 48 silver. That, in essence, it answers our question. They want to know how many black cars and how many silver cars. There it is, 84 black, 48 silver. If they do ask the total amount, well, then I'd have to add this. And if you do that, you get 132. But I'm going to leave it as is. I have 84 black, 48 silver. Let's take a look at 12. And again, feel free to hit pause on your computer at any time and do the questions as I do them. Do your questions as I do them here. All right, let's take a look at Mr. Tanner. He's planning a trip to Las Vegas, which is 500 miles away. I'm going to underline that. As you'll see, I'm going to need that at the very end. I'm not going to need it right away. His car gets 25 miles per gallon. This is a ratio hidden in disguise. It is a 25-to-1 ratio that's not being expressed as we normally like to see it. Because when we think per gallon, we think of per 1 gallon. So it's really a 25-to-1 ratio. And the tank can hold a total of 18 gallons. Now, I could do this with a tape diagram, but I'm going to show it to you using the template ratio because I just think it's a little cleaner and I think it works out a little bit better. I'm going to set up my template, miles over gallons. You could choose to put gallons over miles and it'll still work as long as you stay consistent and put the numbers where it belongs in the template that you've created. I'm going to do miles over gallons because that's the way it appears in the sentence. And I'm going to take my given ratio, which was hidden in that 25 miles per gallon, and that's a 25/1 ratio. For right now, I'm going to disregard this 500 miles. Let's just find out whether 18 gallons, how many miles he can go on 18 gallons based on this 25-to-1 ratio. So I'm going to take the 18 gallons and I'm going to put it where it belongs in the template, and that's the bottom. And let's find out how many miles 18 gallons will get them. That's what we're trying to find. We take a look at the 1 to 18 relationship. We have to multiply by 18. What I do to the bottom, I must do to the top. And when you multiply your 25 times 18, you wind up with 450 miles. That's going to wind up short. He's not going to be able to make it 500 miles on a single tank of gas. He's going to be 50 miles short. So in your explanation, which I'm not going to write out right now because it's just a little bit too long for the blog, you want to explain that he does not have enough gas to get the entire trip. At some point, he's going to need to fill up, hopefully, before he runs out, because he's only got 50 miles. If he goes past that 450 miles, he's going to run out. And you're in the middle of Nevada getting to Las Vegas. Any gas station you get to it. So he's going to need to fill up at some point, and that has to be reflected in your answer, that he's not going to have enough gas on a single fill up. And let's move on to the next question. Before I get to this, I just do want to point out that a lot of these questions are pulled from your previous tests, and just the storylines and the numbers have been changed. So feel free, again, that's why we keep everything. Hopefully you've kept everything in your test section or at home someplace, because this particular drink mix question, I think, if I'm not mistaken, it is exactly the way it appears in your Module 1 test at some point. I might be wrong, I have to check. but let's do it anyway. You have two different concentrations of drink mix. And the same thing, I would ask you to read everything over, get a feel of what we're being asked to do. And after you've done that, to complete part A, you want to take a look at the pattern that's being created in our ratios. I'm going to start here first because we could see from 4 to 8 we're adding 4. And that is our pattern. It's an add 4 pattern. And that allows me to fill the bottom ratios, the missing ratios, the missing values. This one, you have to kind of realize that we're counting by 9s. These are all multiples of 9. And that completes that. And when we take a look at this, we are counting by 7s. And in analyzing the bottom here, you're counting by 5s. And that takes care of A. Now, on your particular question with the two different flavors of drink mix, I believe the question actually asks you to analyze and match up denominators. This doesn't quite say it that way. It's asking you to find which ratios we can use to compare. We want to look for, if we can, common denominators. There is another way to do it with common numerators, but I think in this instance it might be a little bit easier to see why one is stronger over the other by looking at common denominators. So I am looking at these values and these values to see where I have a match. When you do that, you have a match at 20 cups. I'm going to box that. Now, under those two circumstances, when you have 20 cups of water, you're now looking and comparing by the strength and the amount of how many tablespoons of lemonade mix there is. And I think it can be easily seen that the stronger drink mix is going to be 45 tablespoons, which is a lot. I realize that it's just an example. But it's 45 tablespoons of lemonade mix is going to taste stronger than 28. It's going to be sweeter. There's almost twice as much. So you want to say that drink mix 1 is going to be stronger. And I'm not going to write out the entire explanation because of time. When you do write it out, you want to make mention that when the amounts of water are the same, the drink mix that has more tablespoons of lemonade is going to taste stronger, or you could say more concentrated or sweeter. It's all good. But you do want to mention that under a constant amount of water, 20 cups in this case, drink mix 1 is going to be stronger because 45 tablespoons is a lot more than 28. Okay, moving on to the second half of our unit, which is percents. My grayed out boxes are different from yours, but the concept is still the same. Count up the gray boxes. When you do that, you're getting an amount, and in my case it's 78 out of 100 that are shaded. That's what percent means. It means per 100. I have 78 per 100. That's my percent, 78%. To change any percent to a decimal, make believe there's an invisible decimal on the far right, and you leap it twice to the left, creating 0.78. Percent to decimal, we leap to the left twice. If you got to go to decimal to percent, you leap, going back to percent. Percent to decimal, you leap left twice. Decimal to percent, you leap twice to the right. Fraction is already mentioned, 78 per 100. If you want to reduce it, find the value of the ratio, you can, but you don't have to. 39 to 50. Part to whole, no surprise there, it's still 78 to 100. Okay, number 15. 15 is independent, an independent question from this. Okay, some kids think it has something to do with the shading in the boxes, but it's a question that's separate all on its own. I'm actually going to start here because I just think it's a little bit easier to see the pattern and the model. 3% as a decimal. We swing twice to the left. When we do that, there's an empty space here. We have to fill that in with a 0. 0.03. Fraction, 3 per 100. Now we'll work up. We'll go this way first. 0.77, if I'm going from decimal to percent, I'm going to swing to the right 2 places, 77%, and that's 77 per 100. Let's do 0.36, 36%, which is 36 to 100. If we want to find the value, it actually reduces all the way to 9 over 25, 9 to 25. And we'll finish up with 1/10. This is fraction family, which we've learned. Automatically should know it's 0.1. And that's our 10%. Just be careful, it's 1/10, it's not 1%, it's 10%. Let's move on. This question, I remember when it appeared on your test back in the first quarter, there was some issues with this, that this wound up being a little more difficult than I thought it would be for you, so hopefully this will serve to help you to remember what to do and how to do it. Okay, we have a tape diagram here that's divided up into 4 spots, or four segments. We're looking at a total amount in this case of 16 things, 16 items, 16, we don't know, it's a whole number. And that 16 represents 100%. 0% is going to be 0 of those items. So now we just have to match up percent with number. 25% is what fraction of the whole quantity. The whole quantity is out of 16. That's my denominator. Now I just have to find my 25% and match it up with the number, and it's 4 out of 16. Number 17 is asking you to do it in reverse. Find your 12 out of 16, 12 out of 16, and that's 75%. And that's all you really need to do for that. I think the hang-up was where this number 16, this is representing the whole amount. 12, 8, 4 are parts of the amount. And that kind of leads into our next question about part, whole, and percent. It's a good lead-in. 19, what they want you to do for part A is, after reading the word problem, is you've got to identify what's the part, what's the whole, and what's the percent. The percent should be the easiest one to do. That's the number with the percent sign. So my 15% gets the label percent. Where you have to make the critical decision is whether your 40 is representing a part or a whole. You have to kind of get the gist. You got to kind of read carefully and look for keywords. My keyword in this case is original price. Original is indicating that that's the whole entire amount. If they told you that the discount price was 40, that's part. That's not the entire amount. The entire amount is the full price. So they're telling you that the original price, the full price, is 40. So that's going to get the label whole. Therefore, we're trying to find the part. What is he saving? And now we're going to set it up and find out what that savings is. I think the easier way to do this is to use a template, the part to whole template, which was somewhere in the middle of Mod 1, I believe. We just have to now plug in all of our numbers where it belongs. Here's the one that kids a lot of the times forget. The very first ratio needs to be the percent, which was 15. Remember, percent per 100. 15 per 100. Whenever you have a percent, you have one entire ratio. It's going to be that percent over 100 equals. Let's go back to the question, see what we can plug in and where. We have this 40. We need to now know, is it whole or is it part? We've already identified it as whole. And the whole is the bottom part of our ratio, our fine ratio. I'm going to put it here, and this is what we're trying to find, the discount. Now, this proportion that we set up here, it does cause a little bit of a problem that you may not readily see. Some of you might. But when you go from 100 to 40, you know you've got to divide, but it's not readily seen what you've got to divide by. You're actually going to wind up with a mixed number or a decimal to do this. I'm going to take you through the process, but I'm going to show you an easier way, what I'm hoping would be an easier way. If you do 100, and you try to find out, essentially 40 goes into 100 how many times, you wind up with 2.5. And then you've got it, you're still not out of the woods, you've got to do 15 divided by 2.5. Which you can do, and you'll get an answer if you're careful. I think the easier way to do it is see if we can reduce this first fraction, that first ratio. And we can. We can find the value of that ratio. They are both 15 and 100 are divisible by 5. So I'm going to rewrite this as 3 to 20. That's what we get when we take that original 15 over 100 and we create an equivalent ratio, which is really the value of the ratio, 3 to 20. Now, this can be readily seen what our missing value is. Because to get from here to here, you're multiplying by 2. If you do the same thing to the top, you get 6. And that's what our savings are. He saves $6. So what is it that we found? We found that 15% of $40 is $6. There's a third way you could do this, and that is strictly going through pure decimal multiplication. You take your 15% and change it to a decimal, 0.15. You take your whole amount, which is 40, the whole number 40, and you multiply it. And when you do that, don't forget you've got to swing your decimal twice. You get $6. So I've shown you 3 different ways that you can do it. If they ask you, use any method, use the one that works best for you. I do want to show you the template ratio in case they ask you to show it that way. Mod 1 especially was all about exposing you to as many strategies as possible. And so you have alternative ways to figure out the answer to a word problem. Finally, the sale price is going to be the full original price minus what the savings were. and it's $34. And you then put a sentence here, and you're done. All right, number 20. Number 20 is almost the same as number 19. The only difference with 20 is you're going to wind up now solving for the part. Or, excuse me, solving for the whole. In the previous one, you solved for the part, the $6. We're going to set it up the same way with our ratio. Part to whole. Part over whole. Scan the problem, look for your percent. Pull out your percent right away, because when you have a percent, you have an entire ratio. 20 over 100. Question now becomes what to do with the 3 catchers. Is the 3 representing the whole entire team or part of the team? Well, guess what? It's part of the team. It's only the catchers. That goes on top. And they are asking us to find how many total kids there are on the team. That's the unknown. That's what I'm trying to find. We have the same dilemma as we did in the previous question. To get from 20 to 3, it's tough to see what to divide by. I want to see if I could take 20 over 100 and get a value of the ratio. And I can. It's the same as 1 over 5. Equals, watch how easy this now becomes. To get from 1 to 3, a lot easier to get there than it was from 20 to 3. From 1 to 3, it's times 3. Do the same thing to the bottom, and you wind up with 15 total players, and that answers our question. So hopefully this was helpful for you. Again, you may need to go back and look at particular questions again, and but if you keep it side by side and go through it, hopefully these models and these demonstrations will help you to get through your packet, which is going to be due this coming Monday. I also have extra up on Friday morning, starting at 10:15. Feel free to come down if you still have additional questions. Thanks a lot.